gonna stop.
So we're going to talk about radicals again. It's been a while, right? It's been a while because we've been with the other class for a bit. So guys, I've started the video, so we need to keep it quiet. We spent a fair amount of time on a little bit of time on radicals, right? We know how to simplify radicals, right? Everybody remembers how to do that, right? You look for the greatest perfect squares that go into the number, right? So if I had square root of 32 and I asked you to simplify it, I'm looking for my biggest, largest perfect squares, which is 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36. What's my largest perfect square that goes into 32?
16.
So I could rewrite this as the square root of 16. I always put my perfect square first, times 2, right? And that is the same. So guys, please pay attention, okay? The back table, I keep seeing you. I don't see any eyes up here. I want to see the eyes for a minute. Because this is the foundation of the hard stuff we're going to move into, okay? So I just have to be sure you're seeing it. Okay, that is the same as the square root of 16 times the square root of 2. Right? You all see that?
Yes.
That is totally legal to have everything under the square root sign and then break them out into two separate things, two separate square root problems. What's the square root of 16? 4. So suddenly my answer is 4 times the square root of 2. So we simplified square root of 32 into 4 square root of 2 by using our perfect squares as factors of the original number. Okay, so that's the first thing. Can I erase that? Okay, then we talked about, I guess I'm going to do a quick little review of everything we've done so far, so I'm sure that you guys get it. Then we did something like this. We had the square root of 12, well, we'll say 3 times the square root of 12, plus 4 times the square root of 27. And I said, please add them. And how would I do that? Can I add them when the numbers are different under the radical sign?
No.
So what do I try to do?
Simplify them to have the same.
I do what we just did with the square root of 32.
Oh.
I simplify them, right? And I'm hoping that when I simplify them, that I will actually have the same number under the radical sign. Remember that? So we're going to do, let's see, 3 parentheses. What is 12? What's my greatest?
4.
Okay, 4 times 3, right? I could do 4 times 3, and then plus 4 times the square root of 9 times 3, right? Okay, now what is the square root of 4?
2.
All right, so the square root of 4, I'm going to cross 4 out. I'm going to just put a 2 up there for a second. What's the square root of 9?
3.
3, I'm going to cross the 9 out, put a 3 up here for a second. And that 3 is going to be multiplied times that 4. That 2 is going to be multiplied times that 3. So suddenly I have 6 square root of 3 plus 12 square root of 3. So that means I have 6 square root of 3's. Somebody gave me 12 more square root of 3's. How many square root of 3's do I have?
18 square root of 3.
I have 18 square root of 3's. Remember this? Right? It's not that hard, right? Remember this? Yes? Just a 5. So I just need to know where we're at.
Yeah, we have. If you haven't,
No.
We did a whole homework, 2 homework assignments on this.
we did 3 actually.
Was
did.
it the week
You don't remember
everyone
this?
had the plague?
No.
No.
You don't remember these?
No.
But it's the same thing as simplifying.
What we're doing now.
The only reason I can add these is because I was able to simplify them, and they both have a radical of 3.
Gideon, you were here. We literally just like this, like last.
I guess I kind of learned that already, but like, again, I was here, but I don't
Right.
remember it.
Okay, that's fine. So, but it's easy to forget this stuff, right? We haven't done it in like 2 weeks, right? At least,
yeah,
because
it's
we've been
usually
doing it with that other group for 2 weeks, right? So,
It was on
it's easy to forget this stuff, but that wasn't so hard, right? You get it? You see how it works? I can't do anything the way they're written, but I can try simplifying them by using my largest perfect squares, right? And then suddenly, oh great, I have the square root of 3 and the square root of 3. If this had turned out to be 6 square root of 3 plus 12 square root of 7, could I have done anything?
Yeah.
No, I would have had to leave it as 6 square root of 3 plus 12 square root of 7. There's nothing I can do. The only time I can add the coefficients, these are the coefficients, the only time I can add those is when the number under the radical sign is exactly the same. Does that make sense? By simplifying these, I was able to get them exactly the same. Right? Make sense? Okay, so that's that. So we did that. Now, can I erase?
Yeah.
So now we're going to talk about, then we learned about multiplying. And we said, okay, the square root of 2 times the square root of 6 is the same thing as putting them underneath the same square root sign. Meaning square root of 2 times 6, which is the square root of 12. Ah, but then I have to simplify square root of 12.
It's 2 square root of 3.
4 goes into that, so it's the square root of 4 times 3. The square root of 4 is what? 2. So my final answer is 2 square root of 3. Right? You see that?
Yeah.
It's interesting, they gave us factors of 12 that don't have perfect squares in them. Right? But when we multiplied them out, boom, 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 we got a final product or answer that does have a perfect square in it. So then we refactored it with a perfect square and got our answer. Fist to 5, you guys get this? Remember this? Okay, so let's just practice a few of these multiplying. What about this? Square root of 2x times the square root of 2x.
It's 2x.
So, Tia. Square root of 2x times the square root of 2x. So say again. Square root, yes, you can multiply them out. If we multiplied them out, it would be 2 times 2 is 4. X times x is x squared. Ah, but what's the square root of 4?
It's 2.
So wait, 2, what's the square root of x squared? X. So look, that's interesting. The answer is the square root of 2x times the square root of 2x is 2x. All right. Square root of 4xy times the square root of 4xy is 4xy. You guys see the pattern? Right? 4xy. The square root of x minus 7 times the square root of x minus 7 is x minus 7. Okay, the square root of 3xyz squared
Is the square root, no, it's just 3xyz.
Yeah.
Michael, what is it?
It's, multiply everything.
So notice this is the same thing as this, right? Except that I have different numbers under the radical sign. But this, I could have written this as the square root of x minus 7 squared, right? Squared just means it's this inside multiplied times itself, right?
So
Squares and square roots do what to each other? They cancel each other out, right? This square and this square root cancel each other out. So my final answer is 3xyz. Remember this?
Yes.
Okay. So, okay, can I erase?
I'll change my answer.
What time do we have? I have till, okay, 15 minutes. Okay, we're fine. We'll just do a couple more of these. How about if I did this? Square root of 2x times the square root of 2xy. Gideon. Gideon. Square root of 2x times the square root of 2xy. Which parts do you see identical?
The x's and the 2's.
So, what is that? What would that be?
2x.
Ah, so immediately Gideon saw that he could take the 2x out. Immediately he saw that, right?
Totally.
But wait, what about the y now?
This is 2x the square root of y.
Is the y underneath the square root sign?
Yes.
Can we take it out?
No. I don't know.
No, because, no, can't.
No, because there's another
I mean, yeah, you
y.
could do it to the half.
So you keep square root of y, right? Remember this? Remember? Okay, what about this? What about the square root of x to the 4th? What does a square root do to an exponent?
X is half.
It x's it in half, right? Half of 4 is 2, so the answer would be x squared. Remember these?
Yep.
Remember
Yes,
this?
I remember that. Yeah.
Okay, how about this? Square root of x to the 10th, y to the 20th.
That y. X
Yep.
to the 5th, y
It
to
was-
the 5th.
X to the 5th, Y to the 10th.
X to the 5th, y to the 10th.
That's the best lie I've ever seen.
Right.
in my
It's
life.
beautiful.
Thank you.
It's beautiful.
All right,
No.
what about this? The square root of 2x to the 3rd times the square root of 8x to the 4th.
To the 4th.
Okay, guys, focus. What would that equal? I could put them under the same square root sign, right? Let's put it under the same square root sign.
10x.
What is
What's
2 times 8?
plus 2?
No, in the end answer.
2 times 8,
16.
16. What is x to the 3rd times x to the 4th?
X to the 12th.
X to the 7th.
What is x to the 3rd times x to the 4th?
Oh, X to the 7th.
X to the 7th, right?
I can.
All right, so how do I simplify this? How do I simplify this? Cassie,
I really think you.
guys, shh, Cassie's talking.
Don't you like take one from it so it can 6 and then you can like split that?
Yes, all right, so she's saying rewrite it. Can I do anything with the 16? Okay, so I'm gonna cross that out and put a 4 here. So that gives me 4 square root of x to the 6 times x. So keep going, Cassie.
And then 6 divided by 2 is 3.
So that can cross out and we'll put an x to the 3rd up here. That I can't do anything with, right? So I'm gonna leave that there. So it's 4x cubed, which is 4x cubed, square root of x. Fist of 5, you remember these? Awesome, great, good. Okay, so now that's the end of our review. Now we're gonna talk, you're gonna have a bunch of multiplying ones to practice tonight, okay?
Oh.
And then, and I can't remember, oh yeah, and a couple of those addition ones. Okay. Now we're gonna get into the real part of the lecture,
Oh.
which is,
Wait, what is the real part?
the real part of the lecture is dividing radicals, right?
Oh,
Dividing radicals, and a thing called rationalizing the denominator.
That
So-
sounds really hard.
All right,
That sounds really hard.
okay, so you're gonna see, I'm gonna just do a bunch of examples, and it's gonna make sense right away.
It's
Okay.
DRRD.
Okay. All right, so here we go. Here's example number 1. Let's say I gave you the square root of 9/25.
Oh dear.
Now,
That
Oh,
sounds
dear.
very hard.
As- just as in multiplying, remember in multiplying we had like the square root, let's see, how do we do this? The square root of 2 times 3 is the same as the square root of 2 times the square root of 3. I can separate them, right? Right?
Okay, so the
I
square
can
root,
separate these. So Mira, help me.
it would be the square root of 9 divided by the square root of
Okay, now, doesn't that look a little easier?
Yeah.
What's the answer?
Oh,
3 over.
3. Yeah, 3 over 5.
Oh,
Right.
oh.
See, I told you. It would be a piece of cake once you understood it, right?
Whoa, mine
Right?
just blown.
All right, let's try another one. How about the square root of 81 over 16?
Over 4.
So what is it? Right, so London's skipping
it
this step
again.
now, right? He's just doing this step in his head and he's saying, the square root of 81 is 9, the square root of 16 is 4. Yes.
What if it's not a perfect square?
Don't ask ridiculous
Dang,
questions
why do you keep
like
asking
this.
this stuff?
Oh my gosh. Okay. I'm gonna see if they can give us 2 more hours for this lecture.
Oh dear. Oh dear.
Right. Wait. So I'm going in order. Hang on there. Okay.
Oh dear.
So what if I gave you this? What if I gave you this? Now, notice for these two, it was useful to immediately split it up into the square root of 9 over the square root of 25 in our brain, right? That was really easy. It was a useful technique. That's not always useful, so you have to use logic and be sure you're using the right method. So what if I gave you this? What if I gave you this? The square root of 2/32.
Oh dear.
So,
Oh,
Would
God.
we be able to simplify?
That sounds.
simplify, say more.
If we simplified it, then we could just turn it into square root of 16, which is 4.
Well, how do you simplify? Help me simplify.
Divide both the.
Okay, so I'm going to divide the top by 2 and the bottom by 2, right? So that gives me the square root of what, Andrea?
Square root of 16.
No.
Wait, what?
1 over 16. 1 over
What is 2 divided by 2?
Oh, yeah.
Right? So these are the kinds of mistakes you sometimes make, is you forget to keep them in separate. You know what I'm saying? If there's a fraction, there's going to be a fraction, right? You want to keep that. So 2 divided by 2 is 1 over 16. Okay. Now, would it be useful now to do this square root thing? Yeah. So let's try that now.
Why not?
We might just do this in our head, but I'm going to write it out right now. What's the square root of 1? 1. What's the square root of 16? 4. Right? You see how sometimes it's easier to simplify it first, right? Like Andrea said. And then go to this method, right? Okay, so that's
All right.
3.
Let's try to do the
4.
Can we do
Uh,
our homework after?
what if I gave you something like this?
Oh dear.
The square root of,
10 minutes. Ow. Square root of 10 minutes. That made sense.
sorry.
Square root of.
Square
Wait, Gary,
root
can you
of,
square time?
what am I going to do? How about this? 10
Oh god.
sixteenths. Okay. Square root of 10 sixteenths. What would you do?
Right here.
Oh, divide it by 2 again.
You would divide it, but yeah.
But look at the numbers first. Do you see a perfect square already?
Yes.
Yes. 4 under 16.
I would recommend when you see the perfect square, if I could divide it by 2, and then I'd have 5
Over 8.
over 8. But then that doesn't,
That's.
you see what I'm saying?
Yeah.
Then I don't have any perfect square. So it would be really nice to just get that one taken care of. So immediately I'm going to think of it like this. The square root of 10 over the square root of 16, which is the square root of 10 over 4. And that's where I would stop.
Wait, that's your answer?
That's your answer.
Then could you stop elbowing me?
Now
I
notice
don't miss this.
there is a radical sign in the numerator, right? You see that, right? That's okay. It's okay to have your final answer have a radical sign in the numerator, okay? It is not okay for your final answer to have a radical sign in the denominator.
So that's why you're rationalizing.
And that's
the
when we come to what's called rationalizing the denominator.
It's
Gary,
rational.
can
Well
you square time?
said.
It's a.
Can you square time?
Can I erase this so I can start writing I again?
Wait, Gary, can you square time?
He's just naive at the moment.
You just spit
I claim
all
it.
over
I
me,
claim.
basically.
Oh.
Like you're facing the opposite
Oh my
direction
God.
and spitting
What
all over
is
me.
that? Is that you?
Wait, no, I thought it was you.
Oh God. What is
Okay.
that?
that?
Oh my God.
Guys, I'm reminding you that we have a video, right? Okay. Number 5. I did get a message back from somebody. Rarely do I get these, but I got a message from somebody saying, your class is really noisy. That was their message.
That's
So,
good. True.
I don't want it to be too noisy. I just want you guys to keep in mind that we're videotaping these lectures. So let's look at one where it, like Gideon asked,
Oh,
where they don't have perfect square roots.
I
Let's
claim
say,
insanity.
I said the square root of 2/3. Square root of 2/3. Right? I can't do the square root of 2, and I can't do the square root of 3. They don't come out, right? There's nothing I can do. So,
Leave it.
but I am going to do this. I'm going to go ahead and separate them out. Square root of 2 over the square root of 3.
multiply by 2.
And the reason I'm doing this is because it's easier to notice that there's something that's illegal. It's illegal for the final answer. It's not illegal for the process. It's okay in process to have a radical sign in the denominator. It's not okay to have a radical sign in the final answer in the denominator. Does that make sense?
Yes.
It's okay to use it in process. And the reason why, I don't even want to get into that right now. I'll maybe remind me tomorrow and I'll explain to you the reason why on the radicals, why they do this. It's not as important nowadays as it was when I was growing up, right? And I'll explain that tomorrow. I don't have enough time to go into it. So what we're looking at right now is we need to know how to rationalize the denominator, because the denominator right now has a square root of 3 in it. It has a square root in it, and it is not okay. Yes, Mary, have an idea?
Would you multiply them both by 3, and then you would get the square root of 9 and the square root of 6 times?
Well, but wait a minute. Think about this. She's saying this. Square root of 3 times 3. You're saying that's the square root of 9?
What? No, it's not.
It isn't. What is the square root of 9 then? She has the right idea. How would you get the square root of 9? What would you have to multiply the square root of 3 by? Square root of 3.
What?
Then it would give you the square root of 9. Right? Which is 3. Does that make sense? So let's use this concept. We have a square root of 3 in the denominator. That's the only place where there's something funky happening, right?
Yeah.
We have to get rid of that square root sign. So let's multiply it times 1. Times 1. An important one. An unusual one. A weird looking one.
The
The square root of 1.
The square root of 3 over the square root of 3.
Oh.
Right? I know that I need to, if I multiplied the denominator by itself, square root of 3 times square root of 3, I'd get a 3, right?
Yes.
Right? So
Yeah.
let's multiply it times the square root of 3 over the square root of 3.
Yeah.
Isn't that 1? Isn't that the value of 1? It's a weird one, right? It's a weird
still one.
one. But it's still a 1, right? Same value upstairs and downstairs. So therefore, what does that give me?
The square root of 6 over 9.
What's upstairs? What's upstairs?
That'd be square root of 6.
Square root of 6.
Square root of 6. Right? Square root of 2 times square root of 3 is the square root of 6. What's downstairs? 3. Is that legal?
Yeah.
That's legal. That's fine.
What?
That's fine. To leave it as long as there's no radical sign in the denominator. So what we just did is we rationalized the denominator.
Denominator.
That's what they call it. I don't know why the word rationalize, to be honest with you. But that's what they ratio means fraction, right? Rational means fraction. Rationalize, making the fraction
Makes sense.
legal. I don't know. Whatever.
You're an illegal
So
fraction.
6.
Go to jail.
Right.
Get to see
It's
a frowny
illegal
face
to have
before-
inspection.
I
Right.
get to see a frowny
Okay.
face 5
So
over
let's
4.
try another one. How about I said square root of, how about 81 fifths?
Oh, that would be 9 over
That is so close to
the square root of 5.
All right, so you decided to break them up like that, right?
Yeah.
And then you said, well, that's the 9 over the square root of 5. Okay.
But that is wrong.
Okay, well, it's right. It's just that it's not finished, right?
Yes.
Now what do we have to
Sure,
do? We have
it's
to
not
call,
that.
what is it called that we have to do now?
Multiply.
No, rationalize the,
I was saying what we're trying to do.
okay, now, Gideon, what would you do?
You multiply by a fraction of square root of 5 over square root of 5.
Square root of 5 over the square root of 5. Whatever the weird part is here is what you'd multiply it by, right? So equals 9 square root of 5 I can't combine them, right? I just can only do that.
Yeah.
Because there's no square root of 5 that's easy, that comes out even, right? Square root of 5 times square root of 5 is 5. I'm done. That's rationalized. That's rationalizing the denominator.
Okay.
Okay?
We also wrote.
Now, one more example. How about we have the square root of 6 over
Two. It's commercial.
let's do the square root of 12. I'm not putting one of these on the homework yet, but I just want you to see it, okay?
Okay.
Okay, so what would I do?
You do a thing.
I could reduce, but then what would that do? That would give me, that's actually okay, we could do that. Let's do it. Let's do it. So immediately I've got the square root of, I divide this by 6, divide this by 6, right? 1/2, am I right?
What's
Yeah.
your space?
Which is what?
Which equals the square root of 1 over 2.
Right?
The multiplied by 2. Yes.
What is the square root of 1? What is the square root of 1?
Square root of 2.
1
no,
over the square root of 2. Now, Michael, rationalize. What do I do?
Square root of 2.
Over square root of 2, right? Okay.
Yes.
Equals square root of 2 over 2. Beautiful. We're done.
Yes.
right?
Okay.
Okay? I think I'll just stop there. I'm going to stop
Okay.
there.
I'm done with
Um,
this one.
Got it.
All right. Good job, guys.